Today we will talk about instruction scheduling, and it's a very important optimization, and it can increase the performance by several percent. And we will first look at something called list scheduling, which is the basic approach to instruction scheduling, and then something called modulo scheduling, which is an example of software pipelining. So the purpose of instruction scheduling is to avoid pipeline stalls. If we have this left sequence where we start with loading two floating point registers from memory. These are symbolic registers. I mean, they are not real, but we start with that is, the code sequences are before register allocation. But if we execute this, then there will be there is a dependence like this. This add needs these two, obviously, and if they are executed like this, then this add typically has to wait, not only typically, certainly has to wait for at least T3 to get into the register. If we have a superscalar processor, then all these instructions may be executed started at the same clock cycle, and these two may be executed, and then the add has to wait for both of them. So what is better is to change the order so that we do something else while waiting. So now the distance between these two loads and the add is increased, and there is probably a performance improvement. But for this subtract, there is not much we can do. It's the last operation, and I mean arithmetic operation, and then for the store there is nothing we can do either. It's not so bad for stores since they don't produce a value that is needed, so no one is waiting for it. Well, no one is waiting for the value, but the instruction still occupies a resource in the pipeline, of course. So to achieve the goal of reducing pipeline stalls, we separate the producer and consumer of a value. Okay, this separation makes it more difficult to do register allocations, since when we separate, like here, then there are additional values that are live at the same moment. So we increase the register pressure. Then there is also the question, which should we do first, instruction scheduling or register allocation? And the answer is that we should first do instruction scheduling, but keep in mind the register pressure. Then do register allocation, and if there are spills, redo instruction scheduling. So what's the register pressure for these two schedules? The left needs 3 floating point registers, and the right needs 4 floating point registers. Does that automatically mean that this one is slower due to needing more floating point registers? No, not at all. It may be the case that these registers are available to use anyway, so it doesn't hurt. which one is best depends on the context. But just for the executing these instructions, the right one is faster.